Kelly.
I'm Alex.
No, Kirk Cousins 40 fantasy points last week. Let's go!
I'm screaming, I'm trying to learn. Thank you.
Don't you hate it when this happens? You're in class trying to listen to a professor, but all you can hear is the distracting background noise? Well, I'm Morel.
I'm Alex. I'm Uday.
I'm Kelly.
And I'm Neil.
And we're Questions Answered, and today we're going to bring a solution to that very problem. Before we get into it, let me walk you through our agenda. We have our problem, our prototype and solution, our product, our business model, and then our next steps. Getting to the problem. We had many on-campus interviews in which we found that this problem is widespread here on campus. We talked to many students like Tomio and Tina, who told us about how he finds it very difficult to hear teachers' voices in the middle of a classroom with distracting noise. For a different perspective, we also talked to professors like Professor Eric Ellis, who told us that he often finds it difficult to hear students' questions when they're trying to ask questions. So after this research and interviews, we came to our central question. How can we prevent distractions from disrupting classroom engagement? For the solution, I'll pass it off to Alex.
Thanks, Morel. When we were looking for a solution to this problem, we considered four main features. First, we wanted to amplify the professor's voice in the classroom so students could hear them better. Next, we wanted to reduce the side conversations in the room, or at least how much they distract other students nearby. Next, you hear these dim hums from the air conditioning units in the ceiling. We wanted to reduce that noise, so to give the sound in the room a better clarity so you're better able to understand the professor. And finally, we wanted to use recyclable and biodegradable materials in our design to make it circular. So that led us to ProPanel. ProPanel has three main features on it. First, there's the reflector plate. This is a plastic sheet on the front of the design that faces the professor. So when he or she is talking, their voice bounces off of that solid plastic and back out into the room for the students to hear. Next, there's the absorber. The shape of the absorber allows it to absorb students' voices before they can reach other students. And it's also made of a thick, breathable cotton material so that when it's placed under an air vent, it will muffle that sound, but because it's breathable, it still lets the air flow through. On to testing. So we got two main pieces of feedback from testing that we incorporated into our final design. First, we needed to consider how the air would flow through the front of the panel, because there's that solid plastic sheet, so air obviously can't flow through that. Next, we needed to consider how the panels would mount underneath of the air vents, because those come in all different shapes and sizes. To accomplish the airflow problem, we cut small holes in the sheet of plastic so that the air can still flow through it, while keeping enough of the plastic so the professor's voice can still bounce off of it. As for the mounting, we decided to let the middle panel not have a mounting frame and instead be supported by the two adjacent panels via these connecting rods. Now Uday is going to talk to you more about our circular design and product quality.
Thanks, Alex. So circularity was one of the main things that went into designing the product. We wanted to make sure that it wasn't just something that broke once and then you throw it away and never use again. So for that reason, we took serviceability into account. This product is very easy to maintain and repair if need be. And we also wanted to take into account what materials we'd be using for this product. Cotton, as we know, is biodegradable, and plastic is recyclable. So we can use recycled cotton and recycled plastic to make the product, then recycle them when we're done with the product. So it's very circular in that aspect. And another thing that we took into consideration when designing this product is the quality of the product itself. We focused on three main things: serviceability, durability, and features. Serviceability and durability, kind of touched on the previous slide, is very easy to repair and maintain. For durability, there's sort of a trade-off between durability and cost associated with this product. If you recall, there was a plastic frame on the bottom. Now, metal is a more durable material than plastic, but it also costs more. So there's a little bit of a trade-off there. We went with plastic because it's cheaper and it's a little bit more circular than metal is. And finally, the features. This was a big thing that went into designing our product. We didn't want it to be just sound panels because that only has one purpose. We wanted to be able to do a lot of things. So not only does it amplify the professor's voice for the students, it also diminishes student voices amongst each other so they're less distracted. It also reduces external noises like the humming of the AC or potentially like rain and snow from the outside from disrupting the classroom environment. All in all, this is a very quality product because it does all of these things. And I'm going to pass it up to Kelly from marketing.
Thanks, Uday. So when we were designing our product, we really wanted to understand what was already on the market and in the use in classrooms. we discovered that there's three main things. Like you see in this classroom, there's nothing on the walls. That was our control. Other rooms use a microphone, and some rooms in ESJ and VMH also have flat sound panels that are attached to the walls. However, many of those products have flaws. For example, some of them don't necessarily project the professor's voice and also diminish the voice of the student. Furthermore, the features of our product is what really makes us stand apart because it can also be attached above AC vents and we can insulate the room from heat. Now moving on to the marketing strategy. So our users and our buyers are very different. The buyers would be the students in Maryland and on the administrative side and higher education as a whole, whereas the users would be more of the professors and the students who are in the classroom day in and day out. So we targeted UMB because the people that are working on the inside are the ones who are going to buy the product. They're the ones that control the money, and they're the ones who are going to spend money to improve the classrooms. Now moving on to our target market expansion, we currently want to test our product in halls like the Armory, the Chemistry Building, and VMH here in UMB. But after that, we want to expand to the 55 colleges and universities in Maryland before finally reaching the 4,600 colleges across the United States. So now I'll pass it off to Neil with financial analysis.
Thanks, Taylor. So to figure out how and when we're going to be profitable, we needed to figure out three main numbers, and that was fixed costs, total variable costs, and our selling price. So we found our fixed cost to be a flat rate of $6,000. This fee is essentially to send our recycled plastic to producers to cut and mold our plastic portions into the pieces we need. Next, for the variable cost, it's just under $12. That includes the plastic plate, the plastic frame, the plastic rod, and also the cotton material. And we chose our selling price to be just about $20. Next, we calculated our break-even point, and we found it to be 250 packages, which is just shy of $15,000. Keep in mind that in a package, it comes with 3 sound panels and 3 rods. Next, I'm going to pass it off to Morel to talk about next steps.
Thank you. So going forward, like Kelly talks about, we really want to expand our product. We want to bring it into different markets like high schools, middle schools, and offices. We also want to digitalize our products by adding a signal processing system, and the way that works is it will take in any extra sound, clean it up, and then spit it back into the room. Lastly, we want to implement a wall mount, which would be sound panels on the walls for overall better acoustic performance. Thank you. We're question and answered, and we're ready for questions.
So first off, you guys, an awesome presentation. I wanted to add something that everybody mentioned, I think, like throughout the presentation, is that the panels are kind of meant not only to protect the professor's voice, but also to diminish the student's voice, right? So what we got from the initial intro. I'm kind of curious, like I want to hear more about the technical details. Like how does that work? For example, if I'm looking at the teeth and I start yelling at him, like will it be effective in this range? Like what's kind of like the theorized effectiveness of this, and like how did you come to that solution?
Thank you. So the question was, what are the exact technical specifications of the product? And for that, I'll pass it off to Alan.
So the product really works because of the directionality of it. So the front of the product has the plastic plate, and that's really directed at the professor. It's angled towards them, where the back of the product is directed towards the students. So it's really based off the directionality and where the sound is coming from in relation to each sound panel. If you were yelling at a deep, it wouldn't really do much because you're so close and it's on the ceiling. But if you were to yell at someone in the back, or if they were to yell at you rather, then you would not be able to hear them as effectively.
Sounds good, Nick.
I guess a similar question, in the problem you noted how for professors it's very difficult to hear students. So having this muffle facing the students, how does that affect their ability to hear them when they have questions?
So your question was how does having the muffled specification affect being able to hear the students for the professor? And for that, I'll also pass it back to Alan.
So that really works because the sound panels are really designed to prevent background noises, but if a student is still projecting towards the professor, it can still move through this open air space And if the professor was for the same reason as if he was yelling at a beat, they're close enough and there's nothing in between them to block that sound. But if someone was in the back, it would lower the sound, but there's still enough air there, empty air, for the sound not to be absorbed.
That's the time I have. Thank you.